Let us see the experiment 4, which is linear search and binary search. So first we'll write for a linear search. So inside the main, I have to declare the required variables, integer array of 20, which is the array which holds the list of numbers, and I want to search an element, and for storing the array elements I require some index. I'll be declaring I, and storing the number of elements I use the variable n, and for checking whether it is found or not, I'll be using some flag called found equal to 0, indicating it is not found. So other required variables will be adding as and when we require. So I'll be printing enter the number of elements. Enter the number of elements. And I'll be reading the value of n by using scanf %d ampersand n, which reads the number of elements. Now I'll be reading the array elements. So printf enter %d elements /n, n. So now because I need to read array of elements, I require some for loop or any loop. So for I equal to 0, I less than n, I plus plus, I less than n, because the index starts from 0 and ends at n minus 1. So scanf %d % of array of arr of I. So this reads the array elements. Now I have to read the search element. So I will be printing enter the search element. So scanf %d ampersand ELEMENT. Now the linear search works like this. So it starts comparing the array element with the search element. With the index I, you can initialize with 0 or you can initialize with n minus 1. So you can start from first to last, or you can start from last to first. You can traverse in either way. So I'll be using for I equal to 0, I less than n, I plus plus. So I'll be comparing if ARR of I, if it is equal to element, then I'll be changing flag to 1, or that is found to 1, and I will break. So if the array element is equal to the search element, I'll change the flag found to 1 and I will terminate. So outside the for loop, I'll check if found equal to 1, I'll print the search element %d is found at position %d \n, search element is element and position is I. If you want to start the index from I equals to 1, then you can print I plus 1. So I will use the same index as it is stored in the array. So else I'll copy the same, but I'll be printing it is not found. Element is not found. To remove this position is not found. So only one argument has to be printed. So and written and close the main. Save this. Let us compile and check. Enter the number of elements 5. Suppose my elements are 2, 4, 6, 1, 3. And suppose the search element is 6 or suppose it is 3. So you can see that search element is found at position 4 because the position 0, 1, 2, 3, 4. Suppose we enter the number of elements 5. Such elements are 23, 76, 34, 12 and 65. Suppose the search element is not exists. Suppose I give the element as 89. You can see that search element 89 is not found. So other way is you can start comparing the last element at index 1, n minus 1, and here the condition will be I greater than or equal to 0. And here I minus minus. In this case, the elements will be compared from last. So in the same case, the number of elements 5, 12, 54, 32, 45, 89. Such element is suppose 67. Again, you can observe it is not found, and successful search also we will run. Elements 4, 23, 67, 12 and 60. Suppose the search element is 12. You can observe it is found at position 2, that is 0, 1, 2. So this is regarding linear search. You can observe that the array elements could be stored in any order. It need not be stored in the ascending or descending order. But for the binary search, I have to read the array elements in the ascending order or descending order. So this is regarding your linear search. So let us write the program for the binary search. So for binary search, I'll modify this searching method. So reading the elements, everything is the same. So this is for linear search. Then I'll copy the same thing into another program. So for binary search, the array elements, everything is the same, and I require some indexes: first, last and mid. So here reading the number of elements, reading the array elements and search element are the same, and here the way of searching is different. So what I do here is I will take the first index as the index 0 and the last index as n minus 1. Now I will compare whether first is less than last. If it is true, then what I do here is I will find the mid. So mid is equal to last plus first divided by 2. Then I will compare the mid element with the array element. So if ARR of I, ARR of mid, if it is equal to element, then I will change found equals to 1 and I will break. So if the mid element is the search element, then I will change the found to 1 and I will terminate. Otherwise, else if ARR of mid, if the mid element is less than the search element, so it means that assuming that the array elements are sorted in ascending order. So which means that the element is greater than the mid. It means that the search element could be in the second half of the array. So at that time, I'll change first equals to mid plus 1. Else, it may be in the first half. So last equals to mid minus 1. So this repeats as long as the first is less than last. Once it terminates or comes out, I will check if found equal to 1. I'll printf. This code is already there. So if found is equal to 1, then the search element is found at index I, otherwise not found. So let us save. Run it. I have to give the number of elements. Suppose it is 5. Enter 5 elements and suppose I give 20, 12, 23, 34, 56, 78. And suppose my search element is 78. Okay, what is a mistake? Let us verify. Search element is 78 and it is giving not found. So what could be the mistake? We have to check out. So first will be pointing to 12 and last will be pointing to 78. So while first is less than or equal to, it has to be less than or equal to. So we'll copy the same array elements and check. One, 23, 45, 67, 89, and suppose the search element is 89. So you can observe it is found at position 5. So 0, 1, 2, 3, 4 it is. Actually it is 4. Let us verify. This will run with one more run. This is 5. Suppose 12, 34, 56, 78, 90. Suppose it is 56. It is found at position 5. So it means the indexing is wrong. Okay, here the indexing is mid, not the is mid. The elements, so suppose 5, 12, 34, 56, 78, 90. So the search element is suppose 90. It is found at position 4 because it is mid. So suppose it is present in the first half, that case also we will see. So suppose 20, 34, 56, 78, 90, and suppose the search element is 12. So it is found at position 0. So not found case also we will see. Suppose the elements are 6, 12, 34, 45, 56, 78, 89. And suppose the search element is not there. Suppose it is beyond the first half. So you can see that search element is not found. Suppose I read the same array elements. Suppose it is greater than 89. Suppose it is 95. Again, you can observe it is not found. Thank you.